Today we're going to review for our polynomial test. The first thing we're going to need to do is to identify and graph polynomials, and then also identify the parts and characteristics of the polynomials. So first things first, let's take a look at our equation. You can see that I've done a couple of things. I've gone to my calculator and I've typed in the equation. I've pulled up a table, and then I've also got a graph going to a right to see if mine's going to look like this one. First thing I want to do is I'm going to plot some of these points. We have a point at -4, +1. We have a point at -3, +5. We have a point at -2, 3. We have a point at -1, 1. 0, 5, and then 121, which is off the graph. So we can almost do the -5, -15. That would take us down to here, but we can get an idea on this. It would be right around in that area. So when we graph our equation, it matches the picture that we're seeing there on the right. Now we want to identify our roots. Now remember, roots are where we have a 0 value. So we have only one crossing of the x-axis, and we can clearly see that this x-axis so we have a root that is approximately 4. We know that it is not exactly 4 because at -4, this is equal to 1, and at -5 it's equal to 15. So we have a root that is approximately -4. It's not exactly -4, it's approximately -4. Y-intercept, remember the ordered pair for the y-intercept is the constant value, so in this case it would be 0, 5, because if we were to place all of the x's with zeros, the result would be a 5. Now we have only one maximum on this. This does go to a peak at this value right here. We're going to double check that it is exactly that value. Just like I found the I found the x-intercept. Remember, we want to go through the second calculate version of these functions. In this case, we would go to maximum. After clicking maximum, it's going to ask me left bound. I'll move it left of the vertex anywhere on this leg over here. And then it's going to ask me right bound anywhere on this leg, and then we guess. When I do that, it does give me the ordered pair -3, 5. Remember, this is what's called a local extrema. In this case, it's a local max. Local means it's not the biggest one on the entire function. This one actually is a no max or min, no absolute max or min, because it goes on forever. And then it asks us for the minimum value. I'm going to go through the same process. Second, calc. In this case, I'll hit the fifth option, which is minimum, And when I do this, I do learn that the minimum is that -1, 1. Now we need to state the values in which, the intervals in which it is increasing. So as we take a look at this function, we can see that it is increasing from its minimum value to infinity. And we also see it increasing from -infinity until we get to this point. So let's talk about how we write these intervals. We can say it a number of ways. We can say from -infinity all the way up to, in this case, we're talking about the x value, all the way up to -3. That combined with the increasing starting back at -1, remember it's all about the x-axis, not the y, and it's going to apparently increase infinitely. So this is how we would write this particular equation. It's increasing in those intervals. Now, it is decreasing in the intervals between that amount. So it is decreasing from our -3, but not including -3. That's why we will use a parentheses and not a bracket. And it's going to decrease until we get to x value equal to -1. And then the last thing, identifying the end behaviors. So as x is approaching infinity, that means as we move right. So as this is moving right, our function is going to reach to one of two directions, positive infinity or negative infinity. Well, our function is reaching towards positive infinity as we move right. And this function as we move left is reaching to negative infinity. Remember, we're talking about domain and range. It's going to reach towards one of the infinities. So here we are again with another graphed function. Let's plot these points. I see a -212. I know that takes me off the screen, but I can get pretty close to that. We are at -1, 1. We are at 0, 0, 1, 3, at 2, 4, 1, 2, up 4, and 3, -27. So we're way back off the screen. On something like this, you may want to take a look at using your table through different intervals, but let's see what this looks like. And then it's going to make a really sharp downturn because it's got to go all the way down to 25. You can see that my graph is a little uglier than what we got over there, but we can see all of our missing points here. Now, again, we look at the table and we see that we do not have any zero values listed over here. We do a little later, but not on this particular point.
So what you can see is I started off by going y equals and graphing this equation here. If you guys do want to use your cell phones as a calculator today, you can, because we obviously the seniors, but you're not going to use it very much because we'll do a lot of this math. So anyways, we graph this equation, and then I have also a picture of the graph, what it should look like when I'm done. You see that down here. And then I've got the table. When you graph these things, make sure that your table is the way that you're graphing. So even like the -2, -15, I'm going to kind of plot where that would be. It'd be somewhere up in space right there. But the other ones that show up are -1, -1, and 0, -5. Then I see an ordered pair at 1, -3. 2, -1, 3, -5, excuse me, and 4, -21, which is way off the screen here. So this is where I really need that graph on the right to kind of help me see what this is going to look like. So this graph goes down, bends back up, bends back down. I'm going to make sure that that looks like a bend. So step 1, graph, done. All right, as we look at this, what is a root? Very good. Where it crosses the 0 at x, right? So where it crosses the x-axis, here's where we get ourselves into a little bit of trouble when we look at roots. Some of us are going to look at this graph and say, oh, well, -1. It's crossing a -1. But when we look at -1, what do we see? It's not equal to 0, right? So this is one of those where our roots is not an exact number here, but we can see that it is crossing because we went from a negative number, whoops. We went from a, that won't move. We went from a negative number to a positive number. So our roots, we can just put this, is approximately -1. We're not going to go into the exacts of this thing, so it's approximately -1. Most of the others that you'll see on the video are exact numbers, and you'll just list these. This is one of those where it actually gives you a little more leeway on this. Remember, we can do our roots by doing the second calc. Remember this sequence of buttons, second calc, and then we do the zeros. Second calc zeros, and we can get an exact number. But I'm okay with this right now being approximately -1. What is our y-intercept? -5. Remember, this is an ordered pair, 0, -5. Maximum values. Looks like we only have one of those, don't we?
One. Or -1, 3, 2,
Looks to me like that. Remember, we want to get verification on this with our calculator. So we would do the second calc sequence again. And we would go left bound, put it anywhere over here, spider. We would go right bound, put it anywhere over here. And then we would guess and put it anywhere towards the top. And that will give us our maximum value. So just because it shows up in the table doesn't mean it's a max, but this one does check out. So it is -2, -1. We're going to do the same thing to make sure that that minimum, what would y'all think that minimum looks like? Say it again. 0, -5 looks like a minimum. Let's get verification though. So I go second calc, look at minimum, scroll over in left bound, and somebody said this, it's a relative, right? Who said that? That was a good call. Remember, relative, there is no absolute minimum or maximum to this. So this one is 0, -5. And just a forewarning on this, my calculator actually says 4.6903e to the negative 17 power. Remember, that's 0. That's 0. So we have that. You can never go wrong with naming it with a ordered pair. You technically could have said the maximum was -1. You technically could say the minimum was -5. But when you give the ordered pair. All right, now the increasing. Remember, the increasing intervals are just where the graph is moving upward. The only place I see that it's moving upward is actually between our maximum and our minimum. So our intervals of increasing, they're always x values. It is increasing from 0 up to 2. Notice I used parentheses, not brackets. Parentheses indicate that it is not included in the information.
So that wouldn't be -5, -1, because it's gone from negative.
So really, guys, with the graphs we're dealing with, you're either increasing or decreasing. There are no constant values on the polynomials we deal with. So essentially, if it's not increasing, it's decreasing. So the decreasing amounts are going to be everything else. This bar right here, let's talk about how we name that. That is decreasing from -infinity on the x all the way up to 0, isn't it? Then we have a gap in our information. We denote the gap with this little symbol right there. We denote this with a gap on our symbol right here. When do we start decreasing again? 0, 2, so 0, 2. 2 to infinity. Very good.
Is it negative infinity or
Positive infinity. Yep. Because remember, the increasing and decreasing is, think of it as when, as in the x-axis. All right, then end behavior. These are the cheat sheets to end behavior down here. Remember, x arrow infinity, that means moving right. So as we move right in time, that's left for you. As we move right in time, where is this graph going? The further right we go, the further what it goes? Up or down?
Down.
The further right it goes, the further down it goes, yes. So the graph is going to -infinity. And the further left we go, the function goes positive infinity. Positive infinity. And when it's an odd function like this, odd degree function, it should always be that. First off, as we take a look at these, where is it touching the x-axis? 0 and 2. So remember this, x equal to 0, we could waste our time and say x minus 0. But what is x minus 0? X. So we just know that the factor is x. The factor that, that applies to x equal to 2 would be x minus 2. So here's what we get. This says to write this equation in a for the polynomial in a factored form. So we end up with this. But let's talk about some things. I have a second degree polynomial here, don't I? Because I have an x and I have an x minus 2. So I have an even polynomial. Is this thing behaving like an even polynomial, even degree polynomial? What's it supposed to do when it's even? It's supposed to give me both up or both down, right? Odds give one up, one down. Looking at this graph, is this behaving like an even degree polynomial? No. Does anybody know what I've done wrong? I've overlooked multiplicities. Remember, multiplicities have three behaviors. Or polynomial solutions have three behaviors. One of them is a simple pass-through, kind of like we see at the origin. That line is simply passing through, isn't it? That is a sign of a single solution. Then when we get to 2, we have that bounce behavior. It's hitting the 2 and it's bouncing up. Do y'all remember what kind of multiplicity that was indicating when it bounces off of our x-axis? Anybody? That's the behavior of an even one. Write that down then. If we don't have that memorized, we need to know that. So this is an even multiplicity. Now I'm going to tell you for tomorrow, we are not going to deal with anything more than 2 or 3. This one very much looks like a 2 because it's not a very flat U shape. The bigger the degree gets, the more it looks like a flat U. So this is a multiplicity of 2. So if we were writing this equation, this is the way it would be written in factored form. If, tell me if you've heard this story before, if you graph this, it will look exactly like what you see on the thing. If it doesn't, you've got a wrong answer. Guys, there are so many ways that you could graph to get answers on this even without knowing the content. If you know the content, it's a lot faster. It's a lot faster. Now, I just want to talk about this for my own purposes. The ACT is probably not going to have an answer that looks like this. They're going to want it written out. Just remember that x minus 2 squared is write it twice time. It's x minus 2 twice. This is a distribution. I told you we're not spending time on talking about distribution. At this point, we need to know how to do it. When you distribute that, it doesn't become that, it becomes that. Sorry, plus 4. Don't believe me, do it yourself. So on your ACT, likely what the answer is going to be is this. Now, the correct answer, because the question said in factored form, the correct answer is what we started with. I just wanted to make sure that you guys were aware that the ACT is probably going to want to see it this way. You can't have both because they're both equally right. They're both equally right. So again, the main thing we need to recognize, if you learn anything in polynomials, is this. That x-axis is the line. It is the most important line. Anytime our function touches that x-axis, what do we have? A root, a solution, an answer, all of those things. They're all that. But here's the part we've got to recognize. This is actually really easy, and it's kind of the heart of everything we do. If I have a graph that's crossing at 2, that means I have a solution at x equals 2, right? And if I have a solution at 2, It came from the factor x minus 2. We have to understand the heart of all of this polynomial stuff we're doing. This is the heart of it. Anywhere that it touches the x-axis is a solution, and anywhere we have a solution, we have a factor. Right? That gets us a very, very long way. So as we take a look at this, where do we see it touching the x-axis? We see it touching at -3, and we see it touching at 0. Which means we have factors only at x plus 3 and x minus 0. Those are the only factors we have. Now we're going to quickly learn that they're not singular factors. They're multiplicities. Now what is x minus 0? X. And then x plus 3. So this is what we have. It would appear. But this thing moves in 4 directions. It goes down, it goes up, it goes down, it goes up. It goes in 4 directions, which means it should have 4 powers. How many powers do I have? Just 2. I have 1 at 0 and 1 at -3. So I've got a problem here. I don't have enough powers for this many movements. This is where those multiplicities come in. Remember, if a line simply passes through, that is a sign of a single solution. That's what it normally does, is it passes right through. If it bounces, that is a sign of an even multiplicity. It's a sign of an even multiplicity when it bounces 2, 4, 6, 8, 10. I'm making it easier for tomorrow. Tomorrow it's 2. If it bounces, it's 2. And then the third movement we'll see is the wiggle. It will go down to our x-axis, slow down, and then continue going the way it was going. Look at your example 1, that's a wiggle. All right, that's a wiggle on your question number 1. So what action do we have happening at both -3 and 0? The bounce, which means even. Both are to a second power.
So it's even, you square it.
Mm-hmm. We aren't going to deal with 4th powers, 5th, 6th tomorrow. If it's bouncing, it's an even 2 power. If it's a wiggle, it's 3. So this is what we have. This one asks us to write it in factored form. If we were doing the ACT, we would have to write this in a different form. Guys, that's the answer, by the way. Stop. Ding, ding, ding. If you get it, good. Don't let this discourage you. We're not doing the ACT tomorrow. The ACT rarely leaves stuff in factored form. It usually puts it all out. I just want you to remember that x plus 3 squared is x plus 3 times x plus 3.
It's not x plus minus? No, because that would have to be x minus 3 squared.
Yes.
Okay.
I want you searching for difference of squares, but don't make them up. But I like that your mind is thinking about
How
that.
do I tell the difference between a plus?
So we talked about this earlier in the year. We're done working on distribution. You don't believe me that this is this, then do it yourself. But when I distribute these two numbers together, that's what I get. And then we tack on another x squared, so this becomes x to the 4th plus 6x to the 3rd plus 9x squared. So I did all that to show you. Tomorrow, this is what you'll want to be giving me. Your ACT, it's probably going to look like that. All right, now I hope everybody understands this. If you graph this tomorrow, you're going to see that exact graph. All right, I cannot emphasize enough, excuse me, success with a calculator in Algebra 2 is success in Algebra 2. All right, if you can't use that calculator, you're going to make this class a lot harder than it needs to be. All right, I give you every opportunity. I train you as much as I can with the calculator. If you're good with calculator, you're going to be good with Algebra 2. Almost everything we do, there's a way to use that calculator. So that's how you would on this one. You graph this equation. If it looks like that table, that graph, then you have the right answer. If it doesn't, you have a wrong answer. This one is a long division. We could do this one with synthetic division because this does have a leading coefficient of 1, but we're going to practice our synthetic division. Guys, the good news is the examples we did the first time through in class were the hardest ones that I could find. So the stuff that we were struggling a little bit with, you probably should have a little bit because I chose the ones that were more difficult. More likely what we're going to see is what we're seeing right now. All right, so on this particular one, we're going to make, remember, we're wanting our R to match the leading term in the divisor there, dividend, excuse me. So we are going to have to multiply times an R squared to make that happen. Remember, when we are multiplying times an R squared, it's essentially a distribution to our term right here. So you don't have to literally put in these parentheses, but you can. So when we do this, the result is going to go below. R squared times R is R cubed. R squared times 7 is 7 R squared. This is an understood subtraction. I do think it's a good idea for you to put these in parentheses to remind yourself that we are subtracting both of these terms. Now, one thing that happens is what's supposed to happen. We are going to cancel our R to the third powers. And this is 16 minus 7R, which is R squared, which is 9R squared. Remember, we drop down the next variable, or next expression, which is 72R. So now we want this R to become 9R squared. So what does it need? 9R. It needs a 9R. This is an understood distribution to the term in the front here. So 9R times R is 9R squared. And 9r times 7 is 63r. Again, understood subtraction, put the parentheses to help you remember. So the r squareds do cancel. 72 minus 63 is 9r. And we are going to drop down to 70. So this question had the potential of not having a remainder, by the way, because 70 does get divided by 7. Looks like we will have a remainder, though. So now we need to make the r equivalent to a 9r. So we are going to multiply times 9. Again, there's our understood parentheses for the first part. Nine times r is 9r. And 9 times 7 is still 63. The 9r's take care of themselves. 70 minus 63 is 7. So we have a remainder of 7. We can come in here and take care of our remainder by taking the remainder and divide it by what everything else was divided by. Because that's what a remainder is. It means this value was not divided. So the only fair thing to do is to go back and divide it by that amount. All right, so this is what we get for this particular answer. All right, as we look at this question, I know that this one will have a remainder. I know that for a fact. Anybody else know that for a fact? 73 divided by 7 is what?
It's like a decimal or a fraction.
If the last number divided by the last number is going to be a fraction, you know you will have a remainder. You cannot help but have a remainder on this one. Okay? So like the question that there's one of your questions is 70 divided by 7. It could not have a remainder. That doesn't mean that it will be 0, but there's a chance that it could be a no remainder question. This one has no chance. It will have a remainder. Excuse me. So now let's take a look at this. What we're going to do is set up our polynomial long division. So we're going to put our divisor here. By the way, this is one that you could have done synthetic division on because it is p plus 3, p plus 7, and the p is a 1 value. So we actually could have done synthetic division, but we're going to practice this long division. Excuse me. All right, remember as we do these, what we want to do is make this p match the leading p. Everything else is just collateral. So how do I make a p cubed? What do I multiply by?
P squared.
P squared. When I do this, it's essentially a distribution to that number right there. So it's p squared times p, which is p cubed. Those numbers better match or you just wasted your time because we're trying to make them match. Now we have p squared times 7. That is 7p squared. Remember, anytime we do this, it's an understood subtraction, and it's a subtraction from both of those terms. So the p cubes are going to cancel, and the negative p minus 7p is 8p squared. That's where people a lot of times get hung up on this long division. Remember, it's understood subtraction. We're going to drop down our negative 47p. So now our focus has changed from our champion here facing the p cubed, he's now facing negative p squared. So we need to give him the tools to take him on. How do I make a p equal to a negative 8p squared?
Negative p.
Negative 8p, right? Because it needs the 8 and the p. So we go negative 8 times p. The result goes under here. And we go negative 8 times positive 7. Negative 56, right? P. This is understood subtraction. If the parentheses help you, use them. The p's have got to go away. This ends up being 9p. And the 73 is going to take a nice long trip down.
How is that 9p?
Negative 47, and then ends up being plus 56 because
AP's cancel out.
the minus and negative turned it to plus. We do the opposite underneath on long division. Now our last task is to make this p equal to 9p. So the way we do that is with a positive 9. By the way, if I'm ever doing multiple choice, I'm taking a peek at the answers as I go through these. Because a lot of times you may do like a p squared, okay, that's good, and then I get a negative 8p, and none of the answers are negative 8p. I know I've already made a mistake. Does that make sense? So here we go, 9 times p, 9p, 9 times 7 is 63. So those did not match. So we know we're getting a remainder, but we knew that from the beginning. So this remainder would be 10. And the way that we write that remainder is we take the 10 that did not get divided by what everybody else did. Everybody else got divided by p plus 7 except for that remaining 10, so we need to divide it to make it fair. So there's our answer across the top. We can check this in our calculator. If you go and put this into y1 equals, and you go and put this into y2 equals, if you have correct answers, the table will match. Had people in first block saying, so could we just take that on multiple choice? I can't stop you on a multiple choice. So this is a long division. Could we use synthetic division on this one? We could, because the A is an A with a 1 in front of it. So we actually could use synthetic division. If I asked you to do long division, try to do long division. Or vice versa. It says use synthetic division and you're very bad at synthetic but good at long division, show me an attempt at synthetic division and then do the long division. Right? I will be okay with that. You're going to get more credit than leaving it blank. Blank is a 0, guys. You give your teachers no other option other than a 0. So let's take a look at this. This is going to get ugly with the writing with my finger here, but this is too much. Too low. Ax cubed minus 2a squared minus 2a plus 10. And we're dividing by a minus 1. Now there's a chance we could have no remainder here because 10 is divisible by 1. So there's a chance we could have no remainder. That doesn't mean we won't, but we are saying there's a chance. So So we need the a value to become an a cubed. We do that with an a squared. The result is going to go below. It'll be a cubed minus a squared, because remember, this is essentially distribution to these terms right there. It's going to be a little easier on this one because we are dealing with a number of 1. Now, a couple of things. 1, use parentheses and change the sign. Make a recognition that, hey, we are, excuse me, doing the opposite of. So the a cubes cancel, and we have negative 2a squared minus a, which means we now have a squared. My pencil gave up the good fight. So here we go. So we have a squared. A squared. We then carry down the minus 2a. And now our job is to match a to equal a squared. So it needs another a.
Wouldn't it be a negative a squared?
It would be, thank you. So what does that change on the top answer? We should multiply times negative a, right? So negative a times a minus 1 is negative a squared plus a. It's very important you keep those signs because this is a negative a times a negative 1. It's positive a. But we need to remember that this is all doing the opposite of. So these cancel. That ends up being negative 3a. Now we're going to drop down the 10. So we need the a to match negative 3a. By the way, one thing I talked to in my third block about, as I'm doing these, especially if it's multiple choice, I look at the multiple choice answers as soon as I get my second column. Because I've done this before, like your answer, for instance. If I've got multiple choice and then I had a squared plus a, and I look down at the multiple choice answers and there's no a squared minus a, or no a squared plus a, I know I've already screwed up, right? So I can stop and be like, oh shoot, there is no, I have a 3 here, there's no answers that have a 3. That way you don't dig yourself a real big hole and you get to the end and realize, oh, my answer's not up here. You know the second that you made a mistake and you can go back and look. So in this one, we need to multiply times the negative 3. So if I were to have that minus 3 and I look down at all the multiple choice answers and there's no answer that has that, then I know I've already made a mistake. So this is negative 3a. Negative 3 times 1, negative 1, is positive 3. So we do have a remainder on this one. What is our remainder?
13.
Is it? What would it be? 7 again. Not all answers have a remainder of 7, just the 2 we happen to look at. Okay, so remember, the only fair thing to do, take my remainder and divide it by what everything else was divided by. So our answer is that expression right there. Could you put y1 equals the question and y2 equals the answer? Yes. What would we be looking for? Why would we do that? How would we know our answer is correct? And what would we look for once we do that? What? The tables, yeah. Matching tables. Matching tables would be our answer here. By the way, the fraction mode on your calculator is alpha and then y equals. Alpha, the green button, and y equals will let you set up those fractions in your calculator so you don't have to worry so much about parentheses. As we look at this one, the first thing we need to do is pick the number that we are going to run through the synthetic division. The way we do that is we take the divisor, set it equal to 0. Most of the time you can do this in your head, but the number we're going to run through synthetic division is the number -8. So now I'm going to create my synthetic division bars. I'm going to put it this way, and then I'm going to drop this bar right there. Remember, what we input are the leading coefficients. So that would be 5, 50, 71, and -67. And our magic number is going right there. Now, I know that this one is not going to have a remainder. Can anybody else tell how I know that? This will have a remainder, excuse me. I can tell that immediately. Can anybody else? All right, so we all need to listen to this. The trail term is 67, and the trail term for the divisor is 8. Does 8 go into 67 evenly? No. So there is no chance that this will not have a remainder. We will definitely have a remainder here. All right? So let's take a look at this. First thing we're going to do is it always starts with a drop of the leading term. Once this term drops, we will have leading term 5 here. Remember, the term that gets below this sign is going to multiply times our number in the corner, and the result is going to go right there. This would be negative 40. Unlike long division, we do exactly what we see. So 50 minus 40 is 10. So now the negative 8 is going to multiply times the 10, and the result is going to go underneath of that, which is negative 80. And this ends up being negative 9. And then the last one, negative 8 times the 9 gives me a positive 72, which means I have a remainder of 5. Remember, the way we write the remainder is the number divided by what everything else was divided by. To the left of this bar is our constant value, which is negative 9. And then as we move left, we give more x's. So no x's, 1 x's, 1 x's, 1 x, and then 2x, x squared. So our answer ends up being 5x squared plus 10x minus 9 plus the remainder. Could we put the original question in our calculator and the result in Y2 and see matching tables? We better. If the tables don't match, you have a wrong answer, right? So on synthetic division, what we want to do is take what we're dividing by, set it equal to 0, and then we will learn what number we're going to use. In this case, we're using the number 7. So we set up the synthetic division. Notice this one skips powers. Third power, second power. There is no first power. We have to hold its place for the powers. So this would be 1m cubed, negative 7m squared, 0m, and negative 2. Balance this out a little bit here. And remember, the 0 is there because there was no m. We always have to hold everything's place. And the 7 goes in the top. So this is synthetic division. We are going to always start by dropping the 1. This one's going to work out very nicely for us. 7 times 1, the result goes there. Well, 7 times 1 is 7. We do not do the opposite on this one. We do exactly what we're told. So negative 7 and 7 make 0. 7 times 0 is 0. 0 plus 0 is 0. We love our zeros, don't we? And 7 times the new 0 is still 0. And then our remainder is negative 2. We knew this was going to have a remainder from the beginning, didn't we? Because 2 is not divisible by 7. So here's how we read this. Y'all ready? The remainder has to be divided by what everything else was divided by. So that's how we set that up. The rest of it goes this way. To the left is the constant value. So we have 0. And every time we move left, we add an x. So this is going to be 0x. Then this is going to be 1x squared. So what we end up having on all of that is x squared plus no x, so we don't write it, no constant, so we don't write it, and then negative 2 over m minus 7. All right, when we're all done with this, guys, there will be several other examples. I'm doing one example in each of my classes, so when it's done, there'll be 4 of each topic if you want to look at them. Those should be m's. Those should be m's.
Where do you get them from?
What do you mean?
How'd you put them into the equation?
I think what you're asking, these are m's, sorry about that. Well, whatever's left of this line right here is the constant value. So this is the constant column, this is the x column, this is the x squared column. If I had another one, it would have been x cubed. So the results just follow, I said x again, but I meant m. But they always just go in ascending order like that. So your answers across.
So if I have an equation like that, that second number would always be at x, or and the
Yes.
next one would always be x squared.
This will always be a constant.
Okay.
This will always be whatever the letter is to the first power, second power. If we had more, it would be third power, fourth power, just as we go down the list. That's why I draw that line so big, so I know where the real numbers start. To the right is a remainder number, to the left is, and that's why also we have to put them in order at the beginning, right? That way our answers will be in order. When we are doing synthetic division, we have to have all the powers in order, and we have to have all the powers represented. So as we see when we look at this one, we have the third power, we have the second power, we do not have the 1 power, and we have the constant value. So we need to represent these as we do that. Let me take care of this. There we go. So we're going to set up this synthetic division. We need to remember when we get to that point, we need to hold the place of those. So when we have n minus 10 as our factor, the way we decide what we're going to divide by is we set it equal to 0, and the number that we're going to use in the synthetic division is 10. So I'm going to make my synthetic division bars. And then we're going to put in our values. This is 8, negative 80. Remember, we've got to hold the place of the 0, or the n, so this is 0, and then 7. I always drop that bar right there to remind me where the remainder will be. And then the number in the top corner is 10. Is 10. We can use synthetic division on this because our leading coefficient is 1. I showed you guys a trick to doing it when your leading coefficient is something other than 1, but this is one we can definitely use synthetic division. Guys, here's another thing I want everybody to be aware of. A lot of you have been a little discouraged at how difficult the stuff was. All of the stuff we've done so far has been the most difficult version of that I could find. Today's practice test, or whatever you want to call this, is going to be a little more in line with what the actual text will look like. Because when we did long division, I divided by a trinomial. When we did the writing factors, I had terms that had 6 and 7 degrees. All right, so we've been practicing on stuff that's much harder than we are going to be assessed on. All right, so this is going to seem a little bit easier. So let's take a look. Remember, on the synthetic division, the first thing we do, we always drop the leading term. So in this case, we are dropping the 8 to the bottom. We always start with a drop. By the way, I know this is going to have will have a remainder because 7 is not divisible by negative 10. doesn't go in evenly, so I have no choice but to have a remainder when I'm done with this question. All right, so the 8 drops straight down to the bottom. Now the 10 gets to multiply times that 8, and the result goes over here. Something very good is about to happen to us, because what's 8 times 10? 80. What's negative 80 plus 80? 0. We love zeros, right? We're good with our zeros. So now the new number below is 0. So we go 10 times 0. The result is 0. We're good with our 0 multiplication tables, aren't we? And we're good with our 0 addition table, or addition stuff, right? 0 plus 0. Guys are so smart. And then 10 times 0 is still 0. And what is 7 minus 0? 7. Okay. Everybody good with our actions that we were doing there? So now let's interpret it. Whatever's right of the bar is the remainder. So the remainder here is 7. We have to take the 7 and divide it by what everything else was divided by and add it to the end. Remainder means this value did not get divided. So the only right thing to do is to go back and divide it. So here's how we read the rest of this. Immediately to the left of that bar is a number with no variables. Immediately to the left of that is a number with one variable, one power. So this has no n's. This has one n. This has n squared. I think my Apple Pencil finally died. Put up a good fight. All right then. So that would be squared. Squared. So this answer would be 8 n squared, and then we don't have to write the zeros. It just is what it is, right? Everybody good with that synthetic division? All right, I'm going to express this very simply for you. Make sure you're listening to this. There are actually 3 ways of doing this correctly. The remainder theorem can be done one of 3 ways. One way you guys are going to be most familiar with, it's probably going to take the most time as well, and it also lends itself to a little more mistakes. When someone tells me f of x equals x cubed minus 8x squared plus 16x minus 15 at x equal to 2, what are they asking me to do? Not solve, but to plug in, right? Plug in and then solve, yeah. So they're asking me to plug in 2 and seeing what comes out. You could do that. Tomorrow that is acceptable on the test if you do it that way. You're going to be spending more time than this. What is not acceptable if this is on the free response is to do this part with your calculator. I'm not interested in that on this time. You don't hear that from me much, but this is one of those times. If this is multiple choice, all we need to do is type into our calculator the equation, which I did, and then I pulled up the table down here to the right. And all I have to do if I do it this way is reference the value 2. The answer to this is -7. That's a very simple concept, all right? Remember the instructions of this. The instruction says, use the remainder theorem to evaluate the function for the given value. Use synthetic division. I'm going to show you how we use synthetic division because it is actually considerably faster than plugging in, but I don't want you to forget the heart of this question is basically me asking you, what is this equation when 2 goes through it? All right, this is often called synthetic substitution or using synthetic division. So what we do is this. We did not talk about this the first time through because it is not a necessary skill. It's just it's a nice skill to have, especially if you start factoring a lot of stuff. What we're going to do is run the values that we are given through synthetic division. I'll tell you what comes out of this in just a second. So we drop the 1. I'm intentionally doing this one fast because this is the reason why we do this, is because it's a speedy way to get an answer. So you see I ran the number 2 through synthetic division. And what was the remainder? -7. Does that number sound familiar? It was the answer, wasn't it? It was the answer when 2 went in. So when 2 goes in, -7 comes out. We can also solve and do this using what's called synthetic substitution, which is essentially synthetic division. So is this a necessary skill? No, it's not a necessary skill, but it's a very unique and interesting way of doing it. If you get to higher level maths, you will do this because you may only be able to find one factor, and then you use synthetic division to find the other ones that may be irrational. All right, but this is just what that is. Everybody got that? But essentially, remember, the essentials of what's being asked here are for you to plug in 2 into the equation. So when we look at this question, the heart of this question, everybody look at this particular question. The heart of this question is them asking me to plug in -2 in for all of the a's. Do not overcomplicate that. Y'all can read that and see that, right? It says f of a equals 2a to the 4th plus 2a to the 3rd minus 3a squared plus 5a plus 9 at a equal to -2. If that's all that it said, every one of you would plug in -2 and solve this thing out. But when the instructions say, and we'll talk about what these instructions mean, use the remainder theorem to evaluate the function at the given value, use synthetic division. Everybody panics. Remember this, at the heart of this question, we are plugging in -2 and getting a result. Everybody good with that? So when we come to that, that's the heart of this question. Now, at the heart of this question, I'm going to use my calculator because I'm smarter than the average bear, all right? I won't make mistakes other than typing. So if I type this in correctly. So I type this thing in correctly, and then I look at my table. So I type this into my y equals. I look at my table, and instead of plugging in my -2, all I have to do is reference my number -2. So what is the result when -2 comes in? Done. F of -2 equals 3. Done. That is the heart of this question. So the easiest way to solve this is really to just go to your calculator, plug in the equation, look up the number that they want you to look up. Okay? I hope you do that. I feel like that's the smartest way. Put it in your calculator. Option number 2, you can literally plug in -2. Now, if this isn't the free response, the calculator is out of the picture. Now, you can use your calculator to check answers, but we give you the free response because we want to see you work through something. Putting in your calculator is not working through it. So you could plug in -2, solve this thing out. I am not going to do that. All right, I'm going to show you the way what we do with the synthetic division. You're welcome to copy this, but mainly I want you to see this. So we can actually use synthetic division, and it's very fast. So with the synthetic division, we plug in a -2, because that's what they told us to do. And then we fill in the tops, 2, 2, -3, 5, and 9. So here, really guys, this is not a necessary skill, it's a neat skill. It's a neat skill. So watch this. This is oftentimes called synthetic substitution. If you plugged in -2 to this and solved it by hand, it would take you a good bit of time, right? Would you all agree, even with a calculator? Watch how quickly synthetic division goes. Now, I hate to do anything quickly, but it's kind of the point here. So we go 2, that's -4, that's +4, that's 1, that's 3, that's -6. There's the answer, 3. So it's neat how quickly I just plugged in -2. Because what was the answer again?
3.
What did I just get? 3. So here's what we learned. The remainder theorem says when you run a number through synthetic division, the remainder is the output value. Is this a necessary skill? Not at all. Not at all. Now, if you do higher level maths, it is a necessary skill. For our purposes, we can plug in -2 or we can reference -2. All right, so as we look at this question, what we see is we're given an expression, excuse me. We're given an expression here, and we're asked to determine some things about this. Now, one thing we need to understand at the heart of this thing, if you learn nothing else about polynomials, I hope you learn that wherever it crosses the x-axis is a solution, and that solution is directly related to a factor. So if I've got an equation like the one I have on this board here that crosses at x equal to 2, we have to know that this comes from x minus 2, right? This is a very simple skill. It is a necessary skill. We need to understand this. Can I get a rattle? There we go, shake or rattle on this. So yes, we're good with this very question. This is the heart of the polynomials. If we can't understand this, we're at a very, very peculiar situation. So let's take a look at this. I graph this thing, and that's nice and great and everything. When I graph it, it looks like the graph you see down here. But the important parts are this x-axis. Where does it cross the x-axis? So we could pick this thing apart and see where it crosses, but a smarter move is just to look at the table. Because this looks like -1, and it probably is. This looks like -5, and it probably is. And this is probably 2. But our table will tell us we won't have to use the word probably. It will be for sure is. This is. So they ask me about x plus 5 being a factor. How would I determine if x plus 5 is a factor? What number determines that? What references x plus 5 bring us to? -5, right? So I'm going to go look up -5 in my table. Is -5 a factor or a solution? Yes. So this is also a factor. So if we have these charts, these table answers, this is very easy because if I choose equals 0, what does that mean? It is a factor or is not a factor? It is a factor. There are no other options. You should never have equals 0 not a factor. And you should never have does not equal 0 and is a factor. If you choose this one, you should choose that one. So let's look up x plus 3. What's the value that is going to tell us if x plus 3 is a factor? Negative 3. Is negative 3 giving us a 0 value according to our table? No. So this one is not equal to 0, so therefore not a factor. What about the value 2? X minus 2, excuse me.
Yes.
The value 2 is a 0. So yes, it is equal to 0. Yes, it is a factor. And then 4, clearly not. So we have that. So we will have questions like this. I wouldn't have been surprised if you saw that on your benchmark, to be honest with you. If you think back to that, I bet you did see this.